Okay, guys, this is our second lecture of redox reaction, and our today topic is to understand the oxidation number. Before starting this lecture, I just want to tell you something. If you haven't watched the first lecture, which is regarding reduction and oxidation, so please I would suggest you to watch that video first because oxidation and reduction is so important. Without these two terms, you cannot understand anything in this chapter. So if you are watching this video just by missing the first lecture, please don't do it. Okay, now let's come to the topic, that is oxidation number. Now, what is oxidation number? So, what is oxidation number? So, if you look at the Cambridge book or the Pearson book or any international book or the IMAT 650 guide, so they have mentioned different types of definition which is not easy for any student to understand. So I think this definition is simple and clear. Now, what is oxidation number? Oxidation number is charge acquired by single atom. Charge acquired by a single atom due to loss or gain of electron. Due to loss or gain of electron, and I have told you earlier that reduction is gain of electrons and oxidation is loss of electrons. So it means that the charge acquired by a single atom, when that atom is going in reduction or in oxidation, so it gains or it loses some electrons during the bond formation. That's why the charge comes to that element, and that charge is oxidation number. I think for new students this is complicated, but now let's take an example and make this complicated definition a simpler. Okay, so I am taking an example to understand this definition clearly. So this is sodium element. Okay, now I just want to tell you some important point before going further. If there is any element and if any element wants to become stable, now what it will do to become a stable? So what the element do to become stable, they make bond with each other or different elements. Okay, when they will make bond, so they will complete their 8 electrons or octet in outermost shell, so then they can become stable. Without completing the 8 electrons in outermost shell, they cannot become stable. This is the first point. Now the second point, when they complete the 8 electrons, so there is two cases. The first one is this, that to complete the 8 electrons they add some electrons or they lose or remove some electrons. Due to the addition or the removal of the electrons, they acquired some charge, and this charge is oxidation number. Okay, now this is the sodium element, and everyone knows that it has 11 electrons. Okay, now if I want to write the electronic configuration of the sodium, so I can write 1s2, 2s2, and 2p6, 3s1. Now 2, 8, 1. So these are the electrons, and this last one electron is the outermost shell. So it means that in the outermost shell of the sodium element, there is one electron. Now, just assume that this sodium atom wants to become stable. Now, I have told you that to become stable, you need to make bonds and you need to complete the 8 electrons in the outermost shell. Okay, now what we can do, we have two options. First option is this, that we can add 7 electron, then it will become 8 electron there, then it will become stable. Or we have another option, that is we can remove this one electron. So the second option is remove one electron. Okay, so now tell me that which one would you prefer, or which one is slightly easy? I think if I have one electron, so removing it is so easy. But the other thing, to add 7 electron is tough, just because we don't have the 7 electrons now, but we have one electron, and if we remove this one electron, then the sodium atom can have 8 electrons in the outermost shell. If we remove the one electron, so this sodium atom's outermost shell has 8 electrons. And when we will remove the one electron, so it will become Na plus. So now tell me how many electrons we have removed? One. That's why it acquired plus one charge. And this plus one charge is the oxidation number or oxidation state. Okay, I think it is clear for all students. If it is not clear, now let me take another example. So the another example, I'm taking oxygen. So everyone knows that oxygen has 8 electrons. Okay, so if I want to write the electronic configuration of it, so I can write 1s2, 2s2, 2p4. So it has 2 and 6 electrons, and this last 6 is the outermost shell. So how many electrons are you able to see in the oxygen outermost shell? 6 electron. Now this oxygen atom wants to become stable. So I have told you that to become stable you need to make bond, and in order to make bond and to become stable, you need to complete the 8 electrons in the outermost shell. If this is the outermost shell of this oxygen atom, we have 6 electrons. It means we need 2 electrons to make it stable. Now, when we will complete the 8 electrons by adding 2 electrons in it, so this oxygen atom will be like this, O minus 2. Okay, so this charge, how many electrons we have added to the outermost shell of the oxygen? 2. So that's why it has minus 2 charge. Now, first thing, let me tell you, if we are adding electrons, so it will acquire negative charge. But if we are removing the electrons, so it will acquire positive charge. So this charge is telling us that we have added 2 electrons, and this is the oxidation state. If you are not able to understand anything, then it is okay. Just keep in your mind that oxidation number is the charge acquired by the single atom. Because in the IMAT 2025, if you see the PYQs of the redox reaction of IMAT 2025, you will see a one specific question in which they have asked a theory point. So for the perspective of the theory, these points are so important. So in IMAT 2026 or in 2027, they would ask what is oxidation number. Okay, so they can give you 5 options, that a charge acquired by double 2 atoms, 3 atoms, 5 atoms, single atom. So that's why it is so important. I think the oxidation number concept or the oxidation number definition is clear to all of you. Now we have some other points too in the oxidation number concept. So the first point is this: if the oxidation number is increasing, or if the oxidation number is decreasing. So it means if the oxidation number is increasing, it means the oxidation is occurring. If the oxidation number is decreasing, it means reduction. And the third point is this, that the oxidation number can be real or imaginary. The fourth point is that the oxidation number is real in case of ionic bond. So real oxidation number is found in ionic bond, and imaginary in case of covalent bond. So in covalent bond, the imaginary oxidation number can be seen. Okay, covalent bond. Oxidation number can be positive, negative, zero, and fractional. Now focus on the first point. If the oxidation number is increasing, it means oxidation. If the oxidation number is decreasing, it is reduction. Now, I think in the first lecture, I gave you a table plus 5, plus 4, plus 3, 0, minus 1, minus 2, or something like this. And I've told you in that video that if this is something like this, so these are the reduction cases. And if something is going like this, then it is the oxidation. Now, I have told you what is oxidation number, charge, and I think these all are the charges. So if the oxidation number is increasing, see that if the charge is increasing, it means oxidation. If the oxidation number is decreasing, see these are the decreasing case now. So if the oxidation number is decreasing, it means reduction. Now, let's try to understand what are the rules, how we can determine the value of oxidation number. And this is the first important part of this chapter. So, we have 21 rules to determine the oxidation number. Don't worry, these 21 rules are so easy. Once you watch this lecture, so these 21 rules will be so easy for you to understand or to learn. Okay, so the first rule which we have is like this. Oxidation number of element. Oxidation number of elements in their free uncombined state is 0. So first read this statement by yourself. Okay. So every element which is alone and element which is not connected with another element, for example Na, C, Fe, Cu, Zn. So see, these are the elements with free state. They are not combined. What does the mean of combined? So if I have NaC, so if I write like this, now there is two elements. So now they are combined. But now if there is only Na, so the oxidation number of Na will be 0. If any element is alone, then the oxidation number of it will be 0. So now our second rule is this. Oxidation number of elements in their homoatomic molecules is 0. So now read the statement by yourself. So the oxidation number of elements in their homo. So if you know the meaning of homo, homo means same. If there is two elements or three elements, but they all are same. For example, Cl2. For example, N2. For example, O3. And for example, H2. And there are lots of examples like I2, etc. So, oxidation number of elements in their homoatomic molecules, if there is same elements, okay, so then the oxidation number will be 0. Now let's come to the third rule. Oxidation number of elements in their alloy is 0. So, what is alloy? First, let's try to understand what is alloy. An alloy is homogeneous. Homo means same. Genus means species. Homogeneous mixture of two or more metals with metals or metals with non-metals. So the oxidation number of elements in their alloys is 0. And what are the alloys? An alloy is a homogeneous mixture of two or more metals with metals or metals with non-metals. It means that the bond would be between metal or metal, or with metal or non-metal there should be alloy. Okay, in the cases of alloy the oxidation number will be 0. For example, there are few common examples and no one will gonna ask you like extra from these three examples. So what you have to do, you have to just keep these three examples in your mind, that these are the alloys. So okay, let me write it first. So if you see anything, like if there is written brass, steel, bronze, so the oxidation number of these three examples is 0. And if they gave you the symbol, so CuZn, that is brass, FeC steel, CuSn bronze. So the examiner can ask you three type of question from this statement. So the first statement, they can ask you that what is the oxidation number in the alloys. So the answer will be 0. Or the other question which they can ask, they can give you the uh, names of these alloy, brass, steel, bronze, and then they will ask you the oxidation number. The answer will be 0. Or the third type of question, that would be more complicated. They will not give you anything, they will not give you the names. What they will give you, the symbols, and now they will ask you the oxidation number. So the answer will be 0. Now let's come to the fourth rule, which is oxidation number of elements in their allotropic form is 0. So I'm giving you the three examples, and after these three examples you don't need to worry. Just keep these examples in your mind, that C graphite, it is allotropic form of carbon. C diamond. P for white, phosphorus white. So now the examiner can ask you the two types of question from it. They can ask you by giving the statement that the what is the oxidation number of allotrop, 0, and they can give you the carbon graphite, carbon diamond, or phosphorus white, and they can ask you the oxidation number of it, and it will be 0. Now let's come to the fifth rule. Oxidation number of metals in an amalgam is 0. Again 0. So from first rule to 5, there is 0, 0, 0. Everywhere 0. Okay. So now let's try to understand what is amalgam. Okay. So basically it is a mixture of metals with mercury. If any metal is connected with mercury and the symbol of mercury is Hg, if any metal is connected with the Hg, then we consider it as a amalgam, and the oxidation number of metal in amalgam is 0. So for example, okay, uh, NaHg, and as you know, so you can the examiner can change the metal, but the Hg should be there to say it is a amalgam. If it is a amalgam, then the examiner can change the metals, but the mercury will be there. Okay, so the oxidation number of sodium is 0 here. Now ZnHg, it is also amalgam, and the definition mixture of metals with mercury, metal mercury. So it means amalgam 0. AgHg 0. So in like what type of question which the examiner can ask you from here? So the first question is this, that they can ask you the about giving the statement that what is the oxidation number of metals when it is in amalgam, so 0. Or they can give you this type of thing and they can ask you the oxidation number of metal. Okay, it will be 0 always. Now let's discuss the sixth rule of it. So from the sixth rule, so the all the elements will be with some other elements. They will not be alone, because in the first rule I have told you that if any element is alone, then the oxidation number will be 0. Okay. And the second rule, the oxidation number of element in their homoatomic molecule. If the elements are same, then the oxidation number will be 0. Now the elements are with different atoms. Okay. For example, like this, some like OF2, something like this. Now what is the sixth rule? Oxidation number of inert gases, or you can say noble gases, or you can say zero group, is 0 except xenon. So see, these rules are just, you have to keep these rules in your mind, and then you can be able to solve the question. So the sixth rule is oxidation number of inert gases or noble gases or zero group is always 0 except xenon. Now let's come to the seventh rule. It is oxidation number of aluminium is +3. Now let's come to the eighth rule. Oxidation number of fluorine is always -1. So seventh rule is this, that the oxidation number of aluminium is +3. Oxidation number of fluorine is always -1. Keep this thing always -1. Now let's discuss the ninth rule. Oxidation number of group 16 and chalcogens except oxygen is from -2 to +6. Okay, so if you know the what are the chalcogens, so let me write the chalcogens: SETE, sulfur, cesium, etc. Okay, so these are the chalcogen in the periodic table, and the chalcogen group is group 16, and the oxidation number of chalcogen except oxygen is from -2 to +6. See, these are the theory points. So the examiner can ask you in a statement this type of question. So that's why this is so important to keep all this data in your mind. Now let's come to the 10th rule, which says oxidation number of group 15, that is pnictogen, is from -3 to +5. And what are the pnictogens? Elements of group 15 are the pnictogens: nitrogen, phosphorus, like etc. So oxidation number of group 15 elements is from -3 to +5. Again, they can ask you in theory. So now we have few other rules which is left, and we will cover those rules in the another lecture.